Okay.
Yeah, what are we up to?
All right, thank you. So today we're looking at the first part of the normal distribution, just defining what it is. So the normal distribution works for continuous random variables and also when there's a large amount of data. So things like ATAR scores, where there's a large amount of students involved, the normal distribution is used to sort it out. Used for continuous random variables. And graphs of the normal distribution, you may or may not have heard, it's called the bell curve. And this bell curve is symmetrical about the mean. So, for example, if we have something in the means in the middle here, then your normal distribution has this kind of shape, like a bell, and that's symmetrical about where the mean is. Now, if I want to work out an area in between there, I can. So between 2 points A and B, I can work out that area, and then what that area represents is the probability of something occurring in between those values. So the area represents the probability. Alright, so the area is equal to the probability that something is between A and B. The other thing I haven't said it's symmetrical about the mean, the area represents the probability, and also the other thing about the normal distribution is that the mean, median, and mode are all the same. Alright, so if this is the mean, if it's symmetrical about, then that puts this in the middle, which is the median, and then the mode is the one that's the most common, which is the highest point, which is there in the middle as well. So that is a feature of the normal distribution. Alright. So how do we describe this? Well, the mean is used for it, but there's also another one, the standard deviation and spread, because you could have all sorts of vowels that could be shorter and wider, small, narrow and higher. So that spread is to do with the standard deviation, and then where it is determined by the mean. So for normal distributions, we use the mean and standard deviation to tell us about that particular distribution. Alright, so the mean and standard deviation. Are used to describe a particular normal distribution. And so often you'll see it written like this. So you see X with a little approximation symbol, N for normal, so the distribution is approximately a normal distribution, that'll be a number and so is that. And so this here is, number here is the mean, this one here is your variation or your variance or your standard deviation squared.
Is the approximation thing meant to be two curvy lines?
Now in this case they just, yes, but in this case they just use one as what is normally used. And it's kind of describing it as approximate's kind of get out clause, just in case it's not. Alright, so the question is, if this has got a nice little curvy thing here, it must have some sort of equation, and it does have an equation, and the equation of the standard normal, as it's called, and the standard normal is the normal distribution which has a mean of 0 and a standard deviation of 1. So the standard normal, oops. Has a mean of 1, of 0 I should say, not 1, mean of 0, standard deviation of 1. Alright, so we would have an equation or a probability density function. So PDF, probability density function of, and this is the equation, fx equals 1 over root 2 pi. e to the power of negative a half x squared.
Wait, what does PDF stand for?
Probability density function.
Just a function of probability of something to is equal to 1. Graphic equals 1.
Yes, the area under the whole graph is equal to 1. That's correct. All right, so what I've done here, and just someone's written on this board, it's a bit dark and dirty, unfortunately. So here I've put that equation into there, and then I'm going to graph it, and there you go, look at that. Let me zoom in a bit more on, let's zoom in. No, that's not
Just
very
go.
good. Let's go. Oh, stupid box. Gee, I don't know how to operate. Yeah, that'll do. There we go. Little bell there. All right, so this area, because this is a probability density function, this area here is 1. So the mean is 0, so it's about 0, and the standard deviation is 1. So each of these represents one standard deviation from the mean. So you can see 1 either side, there's a fair bit in there. 2 either side, there's a fair bit more. And then by the time you go 3 either side, it pretty much includes just about everything. All right. Now, like any other graphy thing, we can do some transformations on it. So what could we do? Well, we could move it, or we could
Stretch it,
dilate it.
dilate it. No, I said it was like that.
All right, and so when we do that, there's some slight adjustments to this. So this one's for the standard normal. So we're talking about the standard normal has a mean of 0, standard deviation of 1. Any normal distribution with a mean of mu and a standard deviation of sigma has this. So any normal distribution with mean mu and standard deviation of sigma has the PDF. Right, so the difference is fx equals 1 over, still got the root 2 pi, but there's the sigma dilation in there. Still has the e to the negative half, but rather than just x, we've got our transformations, so translation and a dilation. And x can be any real number. All right, so there's some similarities. There's the standard deviation goes there, and we've got this rather than just x. We've now got that. All right. All right, now the other thing is, so if these are transformations, dilations and translations, then there's, and I've rubbed it out now, but there's a relationship between these two things. And so there's a relationship between any normal distribution and the standard normal distribution, and that relationship would be if the probability of x is less than or equal to some number, so the probability of scoring less than or equal to something, that's got to relate to the probability of something in the standard normal. So to denote the standard normal, we use the letter Z. So if ever it says Z anything, Z relates to the standard normal. Alright, and so standard normal, mean is 0, standard deviation is 1. But the thing that I've rubbed out there, the key part is that bit there. So to go from this one, x, to the standard normal, this conversion factor. So what have we got? So probability that Z is less than or equal to A, which is this number here, minus the mean over the standard deviation. All right, so that changes the X in here to a Z, and then you can use the standard norm. All right, how much are we going to have to use that? Not very much,
Okay.
but because our calculator can do it for us. But we do have to know that there's some way that we can go from our any normal to the standard normal and vice versa. And this thing here is our factor, and we'll get to that. All right, so the mean and standard deviation, what do? Quickly. Again, you just got to know what the pattern is. So the effect of the standard deviation is how much spread out it is. The spread, which of course is dilation from the y-axis. All right, so you might have standard deviation, small one. So that's a standard deviation of 2. You might have a slightly bigger one, say 8. And we'll go something like this. And you notice that then now the height, as it spreads out, the height comes down, because remember that area in underneath has got to be equal to 1 if it's for a probability for a probability distribution function. The area under the graph's got to be equal to 1. So if we're spreading out, it's got to get lower. And then, of course, if we go bigger again, it will get lower again. And in the middle is our mean. And if we change the mean, all it does is change the location.
The higher the number is, the flatter.
The higher the number, the flatter it looks, because it's spread out more. All right, so the effect of here is to change the location. we've got something like this, and that's 10.
Listen, I really love your photo.
Thanks.
You've been a lot of interesting places with this in it.
Thank you.
I'm very jealous.
Oh, well, by the time you get to my age, Glenn, you might have gone to a lot more.
No, it's not.
Sound accepted.
In fact, you've probably gone to more interesting places than I had at your age.
I was born in a different country, that probably helps.
When you should take a selfies from the back of your head and you like the documentary of the travelling mullet.
All right,
Mullets worldwide.
Don't watch it at all. Just
nearly done.
it gathers.
Hey, Sana, where's this maths at?
The maths sack
Grades
is
from all over
2
the
weeks
world.
from
The
Today.
17th.
2 weeks from today.
It's on a Tuesday. Maths at. What's the,
Sorry, what did we say about that?
2 weeks from today.
At least it's not next week. Goodness gracious.
We'll finish next Tuesday, we'll finish.
We have Bisman on the same day.
All
You have
right,
a what's that?
Bisman, the chapter's 13 to 17.
Busy minute. And it's only half of it. So you're only doing the case study half.
No, on Tuesday.
Yeah.
We have the first half on the previous Friday.
Yeah, exactly. So you're only doing the case study bit. The second part. Yeah, I'm doing on Monday. I have English on Monday. Bisman Thursday. Bisman next Monday. And this is Tuesday.
All keep the same on object.
Fuck you, dude.
What do you have for doing a uni subject?
Like, which one is the...
I hate to agree with Jordan. Can I read that to you?
No, you disagree with Jordan.
I said I hate to do it. So that's alright.
Sarah, I'll feed you very readily.
Without butter.
Without butter, it'll be like
Fine.
Are we going to do some examples?
yeah,
How is that
gluten-free, sweet-free,
PMU
milk-free,
thingy,
brown.
any, like those 2 graphs, how are they any different?
Because you have
The mean is in a different place.
the y-axis isn't in there, but imagine that like on the left of that left one there's a line up. Look at this. Look at it this way. That's when it equals 0. That's when it equals 5. Sure. So I might miss this in a bit.
all right, so the thing we've got to know about is this thing called the standardised value. Standardised value is Z, and the standardised value is called the standardised value because it relates to the standard normal distribution.
Is this another topic?
No, it's a subheading.
It is actually a different.
Really?
A different chapter?
It's still 16.
These-
It's 16A and 16B, guys.
But these chapters are already timed.
And so
They are.
you put it all together as one.
So is this
That's what I've
like,
done.
is this 16 what?
A and B.
This is B, right?
This is B.
And this is probably B, yeah.
It
A
is.
was just defining all that stuff.
We're still defining it.
Well, it is real, isn't it? Yes. All right. So a few more definitions and then an example. All right. So there's some patterns, conditions, whichever term you would like to call them, that the normal distribution has. So there's 5 that we're interested in. So let's write them down, then we'll do an example, and then Alright, so the following things apply. So the first one is that the integral from negative infinity to infinity of the probability distribution function, fx, is equal to 1. Alright, same for all
PDFs.
PDFs. Alright, so if this is a PDF, then it's got to have that as well. Now remember, the area under these PDFs is the probability. So then the probability that something is between A and B,
Is this an example or is this more?
these
Those
are
are notes.
notes.
So could you say, like, 1, 2, 3?
1, 2, 3, 4, 5. 5.
Again, is that area.
I wrote that as a 1, 0.
And to work out the area, you use calculus.
Correct.
Well, you were lucky. You were lucky that you didn't live in the ancient times.
We did calculus by
I think I
hand.
would rather.
Well, the ancient times we had to do all this.
Our statistics after we get by now
We just like play rocks.
All right, now there's these three patterns that occur in terms of probability. So if the probability of something being 3 standard deviations below the mean and 3 standard deviations above the mean is approximately 0.977. 99.7%.
Is that a 30 or a
It's a 3 sigma.
Sigma. See, it's got its little tail there.
Yeah, well, I just don't know anymore.
Or it's cape, because it's super sigma. It's a cape. So 99.7% of all the stuff fits into that 3 standard deviations below to 3 standard deviations above.
Would that not be 97.7%?
What have I written?
Yeah.
Oh, I've written this wrong.
Okay.
This is a 9. Sometimes you see the words that go along with this, almost certain. So if you're reading almost certain, then this is what they're referring to.
It's the
Who
worst.
wants to read the
All right.
this typo?
There is another, and that's if the probability is somewhere between 2 standard deviations below and 2 standard deviations above,
Why?
and that's about 95%. And 95% of the stuff fits into that.
That's the
Two
last thing,
sigmas.
right?
Yeah, two super
One
sigmas.
more 68.
The second one, and the next one.
And words you might see as most probable.
I hate maths.
Oh no.
It's probably this, but it might not be, but we're not sure, but hopefully it is.
I feel like a couple weeks ago you were like, wouldn't it be nice if they didn't have to ask you an exact?
But like, make up your mind.
Well, how do I-
And then you're like, probably maybe, and now it's like that, you're like, why?
Alice, Alice, because you have to have an exact approximate value.
Yeah, true. I
You
feel
have
like
to be
you can't
exactly
complain
approximate.
that it's not
Question
exact,
mark.
and then it's.
Oh, that says probable. What the heck is probable?
Means likely.
No, I wrote probable.
I could be really mean and say that statistics is to satisfy the pseudo-scientists, but people get upset when you say things like that, so I won't.
So I'm down.
All right, so between 1 standard deviation either side, 68%, about 68% of the stuff fits into that. So if we have a look at, oh, there it is, back on again. Let's see what. Yeah. So let's go Box. There it is. Alright, so really this is our standard one. Mean 0, 1 standard deviation either side.
Oh no.
Right, 1 standard deviation either side. That's a fair bit of space, bit of area in there, isn't there?
Mm-hmm.
When we go out here 2 either side, it's a bit more. And then 3 either side, that's pretty much everything.
But it's not.
So it's 99.7%, 95%, 68%. So for all of those people who think they're special, you must be up here somewhere because most of us are fitting in this
Oh, why is it?
middle bit.
This is loose.
All right. So these three things are given some names. There are a couple of names. They're called is
But the first two are just general rules. So 1 and 2 are just rules of high probability density functions. And then the next very specific standard normal.
Why do you know this, Glenn?
What did he say?
I just listened to what he said.
Weird thing.
I feel like I could definitely teach something I didn't understand. Like, I reckon I could teach methods, I just couldn't do the methods.
I just wish it was.
I couldn't.
Yeah, good. I'm good at acting like I know what I'm talking about.
What happens when you have to help someone?
Well, I just don't help them, I just teach them.
all right. So these three things you might see them talked about as the 3 sigma, 2 sigma, 1 sigma confidence limit. You know, so if you read a question that says with 2 sigma confidence, that means that you're looking at this one here. However, the study design and the textbook refers to them as this.
Give them space.
68, 95, 97, 99.7% rule is what they refer to it as in the study design. Alright, so that's what they're referring to, these 3 things. Alright, example,
I know.
and then we're done. Alright, I'm just going to paraphrase this. So the time seconds. And that's X. If whatever is found to be normally distributed. Where
Standard deviation is 15. I mean,
So I
mean
feel
is,
like
mean is 15 and standard
it would
deviation
really
is
help me
30.
if I'd done the rest of the chapters prior to this. So
Is
it's
the
going
form
on.
squared?
I agree. Yeah, sigma squared, so
The second
why was that deformed, Zeke? It's missing like at least 2 letters.
Really something. And you just make cartons do it.
That's not where I was expecting it to go, but sure.
What did you say?
I think anything can relate.
What is it?
Ruin Mr. Day.
All the power in like control Earth, so all our like apps and stuff are live on
That is like way too easy then.
Not really.
got a good research.
Were you elected? Just be a pain. Why is it immediately like doing classes then? Why is there any electricity? Yeah, but like, why
Is
is
there
there
only A
any
and B?
wires?
Only A and B.
Any part?
Is
Because
there
electricity
room?
goes to the thing that's the easiest part to take. And
I mean, why is it,
I mean, why is it anywhere near pipes? Like, isn't it
you
common
mean
sense?
it'll go into the ground and then come up through it?
You get into the ground and then back up.
Because power takes the power to get.
All right. So here it says it's a normal distribution, 15 and 4. 15 is the mean, 4 is the variance or the standard deviation squared. So 15 and 4, so that means that the standard deviation would be 2. So 68% is what it talks about. So it's 68% because we know our 68, 99, 99.7 rule. And the 68 is the, so right, those numbers 68, 95, 99.7, they need to trigger something. So what that means is it's somewhere between one standard deviation below and one standard deviation above the range of times. So it's simply 15 minus 2 and 15 plus 2. So 13 and 17 seconds. The middle 68% would fit into that range.
Is that question done?
Yeah. That's it. That's that one. All right. Part B says percentage of students expected to take less than 19 seconds. All right, 19 seconds. Now we need to, in this case here, we need to try and relate this 19 back to these numbers we've got here. And 19, of course, is 15 plus 4, which is 15 plus 2 lots of 2, which is the
95% wrong.
standard, which is the mean, plus 2 standard deviations. Well done, Glenn. So, here's our thing, and we've got our 19 seconds up here. Now, here's an interesting question. So that's 2 standard deviations above. If I go down to 2 standard deviations below, this bit in here is how much?
It's 95%.
95%. So
It's
this
2.5% takes less than. Oh, no.
So if there's 95% in that middle bit, how much is there going to be in each of the end bits?
2.5.
That is so-
2.5, because this is symmetrical, isn't it?
No.
Yes,
Theoretically, yes.
it is symmetrical. So that there and that there have got to be the same, and so that's got to be 2.5%.
Wait, why?
So the question asks us what percentage of students to take less than 19 seconds, so that's all them down there. So less than 19
97.5.
seconds would be this 95 plus this 2.5%.
97.5.
Correct, 97.5. So the percentage less than
The maths
Wait, how does he-
19 seconds would be 95 plus.
Because that's the equation that you wrote down just before.
What?
So your mean minus 2 sigma
Yes.
is less than or equal to x.
What have you done on this side?
Which is less
Which
than or equal
side?
to-
Under the
No,
19
I mean-
seconds?
Where?
So you know this,
Here.
look at number 4 that you wrote down.
Right, so I want to relate this
Number 4, did
19
you write them down?
to my mean and my standard deviation.
That's all right?
So I said, all right, how do we get 19 if our mean's 15?
95%.
We've got to add 5
are
to it.
within 2 standard deviations.
A 4 to it.
of like the mean.
Given that our standard deviation is 2, 4 is 2 lots of 2. So what 19 then is our mean plus 2 lots of our standard deviation. So therefore we know then that between that 19 there, 2 above, 2 below, so that number there would be 15 minus 4, so that would be 11 there. So between 11 and 19 there's 95%.
Yeah.
The question asks us for everything below 19, so I need to include this bit here.
Yeah.
Because the 2 standard deviations is 95%, and because it's symmetrical, that other 5%'s got to be split evenly. So there's 2.5% there. Alright, any other? No? Okay, 16A and B.
Yeah, no, same.
How do you know that's 2 deviation?
So pretty
Oh,
much.
'cause I
Yeah, so your sigma squared equals 4.
Yeah.
Sigma is 2. So 2 times 2 is
Just random.
Yeah.
Standardized.
that O would equal, O squared would equal 6, and then O2 would equal 3, and that becomes this.
Oh, yeah. Oh, yeah, so if the sigma was 9, then 3 squared.
Oh, yeah, and bad rules.
I know, but yeah, basically 9. So if that was like 23, for example, 23 seconds,
Yeah.
you go 15, which is your mean, plus 8, which is 3 times 6, 3 times your sigma. So that's talking about all the values.
That's essentially that.
There are default, so the 1 times sigma. They won't give you anything else. Otherwise, they can't.
No, anything else you use your calculator. So this is so that this exam 1, we don't calculate.
I thought we got our bloody summary books.
No, you don't get your summary book, you don't get your calculator.
I'm really
exam
not
1.
keen for exam 1. Actually, no, I am. Exam 2 is going to be so distressing.
Well, because you get your calculator, they can,
Ask you anything they want.
well, and they